Welcome. Today we will be talking about um, limits to infinity and limits at infinity. So to begin our discussion, let's look at this function f of x, which is the fraction 3x plus 3 divided by x minus 2. Recall that this limit doesn't exist because as x approaches 2, the numerator approaches a non-zero number, which is 9, and the denominator approaches 0. So since the limit of the numerator is non-zero and the limit of the denominator is 0, we discussed earlier that this limit doesn't exist. So as x approaches 2, there is no real number L that the values of f of x approach from. So there is no real number L that the values of f approach as x approaches 2, either from the left or from the right. So you can also see that this function is undefined at 2. So even though the limit at 2 doesn't, the two-sided limit at 2 doesn't exist, we still are we still want to know the behavior of this function near 2. That is, when x is near 2 on the right side of 2, what is happening to this function, and when x is on the left side of 2 and near 2, what is happening to the function. Okay, so I claim the following. So this is the same function from the previous slide. The limit of this fraction as x goes to 2 from the left side of 2 is negative infinity. So what that means is that this function decreases without bound as x gets closer and closer to 2 from the left side of 2. This limit, on the other hand, so what is happening to this function as x goes to 2 from the right? Well, the limit as x going to 2 from the right of 3x plus 3 over x minus 2 is infinity. So what that means is that the value of this function increases without bound as x approaches 2 from the right. In other words, it is more appropriate to say the following, that so when we say this limit is infinity, it means that the value of this function can be made as large as desired simply by choosing x close enough to 2 on the right side of 2. On the other hand, this limit here means that to say that this limit is negative infinity, it means that the value of this function can be made as large and negative as desired simply by choosing x close enough to 2 on the left side of 2. Now let's see why. Let's try to get some intuition behind why this limit is negative infinity. So notice that as x gets closer and closer to 2 from the left side of 2, the numerator is getting so when x is close to 2 on the left side of 2, the numerator is close to 9 and the denominator is close to 0. However, since x goes to 2 from the left, it means that x is less than 2, so x minus 2 is in fact negative. So x minus 2 is negative and it is going to 0. So basically then, as x approaches 2 from the left, we are dividing some number approximately 9 by negative numbers that are getting closer and closer to 0. So as an example, let's see what happens when I divide 9 with a negative number that is close to 0. So notice that 10 to the negative 80, that's a number that is close to 0, because what this number is, this is 0.0000000.1, where you have 80 zeros after the decimal points. So this is a very small number. So what happens when you divide 9 with a number that is very close to 0 and negative? Well, you're getting a negative big number here. So this ratio is becoming negative big. Again, because you're dividing 9 with smaller and smaller denominator here. And notice that if I divide 9 by even smaller, if I divide 9 with a negative number that is even closer to 0, so negative 10 to the negative 872, then I'm getting this huge negative number. So that tells you that as x gets closer and closer to 2 from the left side of 2, this ratio is approaching negative infinity. Again, infinity is not a number, so what this simply means that the value of this fraction, for example here, can be made as big as I like by choosing x close enough to 2 on the left side of 2. Similarly for this limit here, so in this case, in this case again, x is going to go to 2 from the right, so the numerator is still going to be close to 9, and the denominator, because x is going, if x goes to 2 from the right, then x would be greater than 2, so x minus 2 would be positive. So x minus 2 would be positive and going to 0. So in this case, the only difference would be that x minus 2 would go to 0 from the right. And so when x goes to 2 from the right, the numerator would be close to 9, and we would be dividing something close to 9 by positive numbers that are getting closer and closer to 0. So when x goes to 2 from the right, this word here would be positive. So in the denominator, we're going to be, the negative sign won't be there. So you can see that we would be getting large positive numbers here. So again, this limit means that the value of the fraction can be made as large as we like simply by choosing x close enough to 2 on the right side of 2. So let's see what's happening in the graph. So here is 2, and you can see that as x gets closer and closer to 2 from the right side, the function goes to infinity. That is, the function becomes large without bound. And as x gets closer and closer to 2 from the left, the function gets large in the negative direction without bound. And so this is so we see that the function has a vertical asymptote at 2. So here you can see that the limit of the function is negative infinity at 2 from the left, and the limit at 2 from the right is positive infinity. So since infinity is not a real number, neither of these limits exists. We call them infinite limits. So even though these limits don't exist as numbers, this information still is helpful in understanding the behavior of the function near the number 2. So once again, the two-sided limit as x goes to 2 of 3x plus 3 over x minus 2 doesn't exist. Like I said, the vertical line x equals to 2 is an asymptote for the graph of this function. Recall that the line x is equal to a, the vertical line x is equal to a, is a vertical asymptote for the graph of a function f of x if as x goes to a from the left or right, the value of the function approaches infinity or negative infinity. F of x will either increase or decrease without bound as x approaches a from the left or from the right. So this simply means that f of x increases without bound or decreases without bound as x approaches a from the left side of a or from the right side of a. Polynomial functions have no vertical asymptotes, but rational functions often do have vertical asymptotes. Okay, so we will end this video here, and in the next video we will be looking at the vertical asymptotes of a rational function more closely.